buenos días, bienvenidos, bienvenidas a esta inauguración del Congreso Internacional Web Engineering. Me acompaña a mi izquierda el profesor Tomi Mikkonen, de la Universidad de Helsinki, en Finlandia, y a mi derecha el señor concejal de Turismo, Comercio y Empresa del excelentísimo Ayuntamiento de Cáceres, don Raúl Rodríguez Preciado. Bueno, yo quería comenzar felicitando a los organizadores, a todo el equipo del profesor Juan Hernández. Tiene un equipo muy potente de investigación en la Escuela Politécnica de la Universidad de Extremadura por la organización de este magnífico congreso, y le doy en primer lugar la palabra al profesor Tomi Mikkonen.
Thank you. Dear colleagues, welcome all to Cáceres, Spain. I am so glad to see so many of you in the audience. My and Ralph's role here in the front row has been to put up a program for you in organizing this event. And I do have to say that eventually, now that we are done the planning part and have started the implementation, I could not feel happier. We received a good number of submissions from all continents except Antarctica. And the final acceptance rate for the research papers was 31%. So for those of you who have a long paper accepted, congratulations. This was really a competitive review, and I'm happy that we were able to pick so many good papers for presentation. In addition to the research papers, we have a couple of other tracks: vision papers, industry papers, and short papers that present ideas or practices that are just emerging, and I encourage you to have questions with the presenters in the time frame, of course, given in the sessions, because we also have a comprehensive other program, like those of you who were here yesterday already have definitely noticed. In addition, I would like to thank all the demo papers and their presenters, as well as the poster presenters. In addition, for the organization part, I would definitely like to thank Juan and Juanma for taking care of us and making such a great effort to have us here in these lovely premises, as well as taking care of a ton of practicalities. On my behalf, welcome to Cáceres. Let's enjoy a great ICRE 18. Thank you.
Thank you very much, Professor Mikkonen. Tiene la palabra el señor concejal de Turismo, Comercio y Empresa del excelentísimo Ayuntamiento de Cáceres.
Good morning. I want to thank, on behalf of the city of Cáceres, the organization of the International Conference on Web Engineering, having chosen this city for such an important appointment. It is a World Heritage City granted by UNESCO since more than 30 years ago. Since 1968, it holds the title of Third European Monumental Complex, and by extension, first monumental complex of Spain, declared by the Council of Europe. This monumental setting of Cáceres and its exceptional conservation made the historic center of the city a place that transports visitors back in time. Precisely, that unique feature has transformed the monumental environment in a landfill set that has hosted the recording of many series and historical atmosphere films. One of the producers that landed in Cáceres was HBO to record various scenes of the popular Game of Thrones series in 7 seasons. In this moment, a novel project for the control of visitors in this city will be launched within Red.es. The overall budget is 4 million euros. Our goals are preserve, value, and publicize this heritage, acquisition of greater knowledge of the behavior of visitors and citizens in their relationship with the city. The system that is contemplated is to include automatic mechanisms that allow knowing in real time the state of heritage and the behavior of those who visit us. I hope these days are very useful for your profession and take the time to get to know the city. A city that welcomes you. Thank you very much.
Okay, thank you very much. My first words is for say thank you, Professor Juan Hernández. Congratulations for this conference. We are very happy with your work and with your research team in the Polytechnic School in our university. And welcome to our university. We are a very young university. The last week we had a very important meeting in Salamanca. Salamanca is the ancient university in Spain. They have 800 years of history, but the University of Extremadura was born in 1973. We have only 45 years. We are a very young university, but we have about 21,000 students in Cáceres, in Badajoz, in Mérida, and in Plasencia. We are very happy that scientific people from all the country in the world can arrive to our university. I think you can pass a very nice time with us. Maybe it's a short time, but you can enjoy with our city, with our food, with our wine. I think you have a good opportunity for enjoying this time. And if it's possible, you can return with the family for spend more time in Extremadura and in Cáceres. Disfrutad del Congreso, disfrutad de esta estancia que os permite hacer estos encuentros. Estamos encantados de que estéis con vosotros. Estamos encantados de la organización llevada a cabo por el profesor Juan Hernández y su equipo. Acostumbrados nos tienen los compañeros de la Escuela Politécnica a organizar eventos de altura y estoy convencido que en este evento no nos vamos a quedar atrás y que va a ser muy importante, tanto desde el punto de vista personal como desde el punto de vista científico. Aprovechen el tiempo, ténganlo siempre presente. La Universidad de Extremadura tiene un carácter internacional. Estamos encantados de que estén con nosotros y os deseo una feliz jornada. Muchas gracias.
One of the original promulgators of self-oriented computing, and he was the scientific So good morning, everyone. Where did I put the mic? Good morning, everyone. It's a real pleasure to be here with you today in this beautiful city of Cáceres, surrounded by such nice people. I'd like, first of all, to thank the members of the organizing committee, especially Juanma and Juan, for the invitation. It's a real pleasure to be here, like I said, with you before, and to give a talk on a topic which is very close to my heart. We started an interest group in the area of smart data and applications probably about 3 or 4 years ago. And this is the summary of some of the activities of that group, and it has also a personal touch and a personal feel to it, and I would like to share my ideas with you today. I will start first of all with a disclaimer. The application area that I will be talking to you today is medical information systems. I am by no means an expert in that particular area. The area of my expertise is digital manufacturing, and in particular laser machines for aerospace turbines, but it's a very complicated area, so I thought I'll probably present something which is much more easier and simpler for you to understand and digest. So let me get, without further ado, to my presentation and just give you a glimpse of what I will be presenting today. This doesn't work. Brilliant. Should work now. Yeah. Finally made it. So this is a broad brush overview of my presentation. First of all, I will start with a broad vision. Then I will be talking to you about enabling technologies. I will give you some definitions about smart data and applications. Then I will delve into examples from the area of smart healthcare, and I will talk about application challenges. And finally, I will be talking about support frameworks, frameworks in particular which are based on different types of technologies that I will touch during my presentation, which are supporting these types of applications that I call smart applications. And of course, I will close with some general remarks. So let me start. Okay, let me start with the vision. So what I am talking about today is smart applications. I call these applications smart industrial strength applications because basically we are very much interested in very complex applications, and these applications have different characteristics from the applications that people normally refer to as smart applications which run on your let's say phone or whatever sort of let's say computing installation. Now we are surrounded by a lot of developments today. Data analytics, big data, cloud computing, services, complex cyber systems, whatever you wish to call them, and so on and so on. And basically, the culmination of all these types of technologies, if we consider them in tandem, is something that I call smart solutions. So smart solutions are more automated solutions, interconnected solutions, interoperable, that lead to improved decision making and complex problem solving. And this is going to be the theme of my talk today. Now, some of the applications that I have in mind, you see here. We have applications in smart traffic, smart cities, smart agriculture and food systems, smart healthcare, smart businesses, smart supply chains, and the like. And what I'm going to be doing today is I'm going to be using applications which refer to that particular area, smart healthcare, but they can equally apply the technologies and the techniques that I mentioned to you, they can equally apply to different types of applications. So these are very generic types of solutions and ideas which are applicable to many, let's say, industrial domains. Now, I sort of flooded you with lots of buzzwords. Smart data, smart solutions, smart applications, and the like. So let me be somehow more concrete. Let me give you some definitions. So the first thing that you probably ask me, what is smartness? So smartness is the ability of applications to have an unobstructed visibility of services. You have myriads of services which are working together, so you need to know what these services are doing at any point in time. So you need to have some global visibility, if you wish. You need to optimize the use of resources. You need to provide help and guidance for making efficient and effective decisions, and this has to do with human operators which drive these applications, because these applications are very much human-centric applications. And of course, you need to plan a coordinated response to individualized application needs. And we're going to see some of those concepts and some of those ideas slowly throughout my presentation. Now, let us look at some of the technical features of these applications before we get into more concrete ideas. So smart solutions or smart applications, these are modular solutions for every stage of the life cycle, starting from the conceptual design, if you wish, down to the implementation and to deployment. And of course, you need to enable continuous service improvement. So you need to learn from the experiences of past runs or past executions of your applications, and you need to try to optimize and improve the applications as you go. So these applications are being monitored, they are smart, of course, and they need to react to all sorts of conditions, environmental conditions or whatever conditions, and they need to improve themselves gradually. Now, the other thing which is very important is we need to translate business requirements or application requirements, read for business requirements, application context, application requirements to IT assets and support the delivery of smarter data and services. So my talk is going to concentrate on smart data and services and of course the applications that these data and services can realize today or tomorrow actually. So smart solutions combine user, structural, and operational insights. And this is really important. So you have a view, a multidimensional view of different, let's say, factors which are really important for an application here. And of course, they utilize predictive and prescriptive analytics and with modern development tools and a user-centric design to create a more compelling and more prescriptive experience. So basically, what you need to do at the end of the day is you need, let's say, your application to help the users understand the context of the application and come up with better decisions and much more flexible and usable solutions. So these smart applications not only know how to support and enable key user decisions, but they continually learn from the user interaction. And this is an important point. So basically the application, if you wish, the system which relies behind the applications, tries to understand what the user wants and learns from, within inverted commas of course, from the user experience and tries to become more relevant and more focused and more valuable to those users. So this is a sort of a slide which is a little bit overloaded, but it sort of tries to capture different aspects of my talk. And in the next slide, I'm going to give you a glimpse of what I call smart data. So smart data is, of course, very central to these types of applications that I talk about. And in particular, I'm going to use examples from healthcare. Now, the term smart data emphasizes latent value, which is inherent in widely dispersed data and unconnected data sources. So we have a large number of data sources which are unconnected, and what you need to be doing at the end of the day, you need to connect those sources of data, you need to cross-correlate the data, and you need to make sense out of these myriads of data which exist out there. And of course, these data are very specific to the application in hand. Now, if we look at smart data, then we're going to see that smart data has the following properties. First of all, data is normalized, so it has to be conflict-free. So the arrangement that you have here is that you need to homogenize the data, which is retrieved from multiple sources, which are related, of course, sources, and sources related to the application that you need to solve. and they need to be interpreted in a specific context. The specific context is going to be a part of a medical application. For example, the treatment of, let's say, hepatitis B or whatever here. So let us look at some of the raw data which are behind these normalized data. So here we have patient summary data, results and reports, including images, of course. So you have diversity of data, of course, different types of data. You have requests and referrals, you have prescriptions, discharge notifications, screening tests, and the like. So this is the raw data that I'm referring to. And this data, of course, exists in many sources, and what you need to do is you need to try to bring it together so that they can solve the problem that you have in hand. So let us look at what happens here. The next thing is that your normalized data becomes contextualized. So you try to give emphasis to the context of the raw data that you're going to be using in terms of the application that you want to solve. So contextual awareness is if you wish, a property of your data, or the smart data, to enable orchestration and improve decision making. And decision making is really important because, like I mentioned to you before, these applications, of course, they are automated, but they're driven always by a human operator or human operators. So in other words, these applications need to help the users solve the problem in the most appropriate way. Now, what are contextual data? Let's assume that we're talking about cardiovascular risk assessment data. So all these data need to, which are here, they need to refer to this context, cardiovascular risk assessment. So we talk about historical patient data, which refers, of course, to cardiovascular diseases, blood glucose levels, screening tests, life cycle data, nutrition data, and the like. And these data come from, of course, from the raw data, and there's additional data to it, which I didn't, of course, let's say, note under the raw data. But you get the idea, I hope. Now, the next step is we need to give a bigger picture to our data, and basically what happens to the contextualized data, they become orchestrated. So basically we take data from the different sources, we cross-correlate them, we put them together so that we can create a holistic view of the data so that we can solve the problems that we have in hand. And what happens here is the data, like I said, is cross-correlated across a specific domain, and it can be turned into actionable tasks. And of course, this helps us solve a diversity of problems. So what are, let's say, the actionable tasks here? For example, we have diabetes 2 treatment. Now, what we try to do here is we created a context for cardiovascular risk assessment. We need to take that into account. However, this is not enough to, let's say, cure a patient who has diabetes 2. So you need to link it with other, let's say, contextual data, like intensive behavioral counseling, treatment of metabolic disorders, lifestyle modifications, pharmacological options data, and so on and so on. A lot of information which is contextualized comes together, gets cross-correlated, and it gives you the entire picture so that you, at the end of the day, as a doctor or a physician or whatever, you are in a position to understand what the patient suffers from and try, of course, to help the patient cure the disease or at least alleviate the symptoms that he or she is having at the moment. So this is the general idea of smart data. So let us look a little bit further. If we start from smart data, let's see how we move to smarter analytics, because this is also very important. Smart data supports smart analytics. So here we have our data, which are smart data, and we apply analytics techniques. We need to understand what is happening with our data. So we have descriptive analytics. And of course here we need a lot of human inputs. And we have decisions at the end of the day, and of course actions. Now we have diagnostic analytics. If something has happened and let's say a particular patient suffers from a particular symptom, we need to understand why it did happen. Did this person, let's say, change his, let's say, dietary requirements? Did he change lifestyle? Or did she, for example, had to go to a conference or a sort of a trip abroad and ate something that didn't fit in her organism, for example? So we need to understand what's going on. And then we have predictive analytics. So what will happen if we start, let's say, curing this patient and giving her different types of medications? So is she going to get completely cured, or does she need to go to the hospital, for example, and have another medical treatment, or does she need to go to the emergency ward? Things like that. And of course, at the end of the day, we have prescriptive analytics, and this prescribes what we need to do. And here we have a lot of decision support, which is automated, but at the end of the day involves a lot of actions, and of course involves human operators who receive the information from the application context and are in a position to react to the information which is provided. So I hope that this gives you a glimpse of what I call smart data and smart applications. So let us become more concrete. So let us look at how we can have an integrated medical world. So like I said before, you have many, let's say, points of care and many sources of data. And if we look at some of those, and I mentioned quite a few of those before, you have aggregation of clinical information across hospitals and hospital providers, immunization histories, medication lists, allergies, and all sorts of, let's say, if you wish, treatments that happened in the context of a particular, let's say, patient. And of course, you also have clinical messaging. So this involves a medical provider, interaction between a medical provider and another medical provider. So here we have laboratory tests, we have e-prescribing, case reporting, electronic laboratory reporting, ancillary referral services, and so on. And finally, if you want to integrate healthcare, you need to connect doctors with patients, with hospitals, with medical diagnostic devices, with patient-embedded devices, with laboratories, with medical homes, and of course, all sorts of health information systems. So you see the magnitude of the complexity, or the scale of the complexity that we are facing here. So these are the types of applications that we have in mind. And basically what we try to do here is we try to look for solutions, technologies, and of course methodologies which can support these types of applications and can solve such complex problems. So let us look at some of the enabling technologies. Of course, the web is paramount here, so I don't refer to the web explicitly, but as you're going to see, all the technologies that I am introducing or I am hinting towards, they have to do something or other with the web. So the industrial internet is the core of these technologies. And when we talk about the industrial internet, or the internet of everything, if you wish to call it this way, you have to have data. And we mentioned data already. You have to have services. So this is where service-oriented computing comes into play. And of course, you also have things, and this is really important. So we're talking about IoT and all sorts of, let's say, sensors and physical devices which broadcast huge numbers, huge volumes of data. And at the end of the day, something really important, you have people. So people are very much part of the equation. And this is really important, and I'm happy to say that there's a lot of interesting research which is happening here in Extremadura, in the University of Extremadura. There's a group which is very much involved in the area of, let's say, looking at requirements of people, of users, and expressing those requirements as services. So this is very interesting work that these guys are doing here. Now, if we look at the industrial internet, I'm claiming that is big science. Why is it big science? Because it involves a number of disciplines which come together and they contribute to the solution. So these solutions are multidisciplinary solutions. There's not a single technology that contributes and solves the problem. If you are thinking that this is the case, then unfortunately the solutions that you have to develop are much more complex than that. Some of the contributing disciplines I mentioned already. You have big data, analytics, and machine learning, cloud computing, service-oriented computing, distributed systems, cyber-physical systems, sensors, and IoT, visualization and augmented reality, very, very important technology, and we come to that. Domain-specific languages, service and software, and web engineering, of course. So these are some of the technologies which contribute to the solutions that I will mention to you in the next few minutes. So let's look at biosensing. So this is one of the technologies. What I do have here is I have a brief explanation of the technology. It's not necessary to concentrate on that, but these are wearable medical devices. So these are devices essentially that the patient, as you see here, has on his or her hands or body, and these measure all sorts of, let's say, symptoms that, of course, the patient is suffering from, let's say, blood pressure, analysis of glucose, what have you, and they emit continuous, let's say, signals and data, of course, to a centralized location where this data is being analyzed, and the doctors try to intervene very, very quickly if the symptoms become critical. Another technology is cloud computing. I'm not going to say anything to you about cloud computing because you're much more experts than me here. Now, augmented reality, this is really important. It's a really important technology for people who are interested in the user interfaces of the future. So in the future, user interfaces are going to be using augmented reality. So we are talking here exceedingly about three-dimensional images, three-dimensional aided design, computer-aided design for healthcare. So basically what you do here is you simulate, you project the images on the screen, you try to analyze the procedures, you try to analyze the solution and of course, the treatment that you're going to apply to the particular patient or maybe the operation, and you try to understand the results by looking at them from different angles. So this involves a lot of simulation, by the way. So these are used currently for prevention, diagnostic assessment, of course, and treatment and treatment of chronic diseases. So we manage chronic diseases by using these types of technologies. And this is really important. So in the future, we're going to see many more of those technologies replacing the current user interfaces. So this is a hot area of research. Now, if we start looking at the implications of the industrial internet and these smart types of applications, I have a slide for you which I pinched from General Electric. So this is not my slide, of course, and it mentions a few interesting statistics regarding the implications and the importance of these types of applications. I'm not going to go through all of them, of course, because there's quite a few. But what is staggering here is the fact that we're talking about, let's say, huge numbers. So they estimate, GE estimates, General Electric estimates that by the year 2025, we are talking about application areas and application sectors which account to more than 32.3 trillion of US dollars in economic activity, which is a staggering number. And if we split that into application areas, then in the area of applications where we are currently extremely active, you see that you have an estimated value. This is going to generate about $30 billion in the next 10 or so years. Actually, these slides are a little bit older, so they're about 5 years older. So, of course, in today's numbers, they need to be slightly modified. So you see here the implications for healthcare, and we're talking about different types of segments, of course, here, and the savings that you, of course, let's say, achieve, and of course, the estimated value. And as you see, these numbers are extremely important. So there's a lot of, let's say, interest in these areas, and at the same time, there's a lot of funding. So a lot of funding is moving to areas like the ones that I'm talking about, smart application areas, if you wish, which involve, of course, quite intricate research. Now, let us delve a little bit deeper into, let's say, the applications themselves, and let's try to understand the context of these applications. Now, if we talk about smart healthcare, we talked about different types of technologies, and we mentioned, of course, IoT and embedded devices and so on. And here, what we have is we have a patient who has a number of embedded devices here. And of course, these devices, at the end of the day, they emit information which goes into the central location, for example, the hospital, And if this patient has a crisis situation, then the operating theater is immediately prepared for them. So basically the idea is you're dealing with patient-centric, let's say, healthcare, where you try to prevent a disease from escalating, and if there's a critical condition, then you're ready to operate on the particular patient if the risks become quite high. And you do that because simply you receive a lot of data from these sorts of devices which are embedded on the particular patient. So if we start looking at these types of applications, we're going to see some interesting results. We have a lot of information, we have a lot of services which we need to organize. It's completely disorganized, it's in different locations, it's in different health practitioners, in different doctors, in different hospitals and so on. So we have a mess regarding all this type of information and services. What do we do with it? What we need to do is we need to be able to apply engineering techniques. And in particular, what we have been doing, we have been experimenting with a model, a medical model, which we call a 5x5 medical model. So if you look at the left-hand side, is you have 5 medical resource object models. So you have the stakeholders, so here you have the patients, you have the doctors, the nurses, the laboratories, the medical professionals, and so on. You have patient care devices and equipment, and we saw quite a few of those. You have the medical records and the tests, and these might be very dispersed. A person like me, for example, I don't have all the information in one location. Since I visit a lot of countries and I live in different countries, then my medical record is very much dispersed. And at the end of the day, they need to collect all this information. If something happens to me, and they need to cure me. So these are the medical records and tests. You have the medication, and of course the medication involves a lot of information about allergies that the patient may have, and it's very personalized. And you have medical pathways. So medical pathways are the workflows or the processes which solve the problem. They cure the patient at the end of the day. And on the right-hand side, you have information like capacity, schedules, flows, safety, and performance information, which is interconnected to these 5 medical resource object models. So capacity is what is available to use to cure the patient. Doctors, for example, let's say operating theaters, nurses, machines, for example, specialized equipment, what have you. The patient symptoms to cure. The safety procedures, because you have a lot of safety procedures, all sorts of regulations and clinical practices. The medical schedule and workflow that you need to follow. So this is coordinated care, is how to cure this particular patient, what to prescribe, what sorts of medication, lifestyle changes, environmental changes, whatever. And of course the performance. So what was treated, how did we treat the patient, were we successful, what did we achieve, what resources we used, and how we can optimize and improve these resources in the future for future patients who have exactly the same symptoms. So this is in a nutshell an organization or a structure for this disorganized world which has a lot of information, see data and services which are dispersed all over the place. Now, if we look at some of these examples, so we talked here about stakeholders. So what I'm going to do is I'm going to take some examples from these 2, let's say, areas, and I'm going to explain to you what they mean. I cannot, of course, let's say, delve and analyze all of them, but I'll use some examples just to show you what I mean. So let's look at the first one. The first one is about stakeholders, the actors here. So you have healthcare providers, healthcare facilities, clinicians, nurses, clerics, what have you, laboratory providers and stuff, technicians, data managers, managers of laboratories and so on, public health staff. For example, if we are interested in diabetes type 2, then of course we need to take into account the public health let's say providers who try to cure this disease, the program staff, And finally, of course, we have to have information about the patient himself or herself and what type of problem this patient has. And in this particular case, we assume that the patient is suffering from diabetes type 2. Now, this is an example of the medical pathway. So these are very standardized workflows. So these are workflows which are repeatable workflows, standardized workflows which have been used for many, many years because they are tried and tested, let's say, if you wish, ways and means or pathways to solve this particular problem. And as you see here, they involve different actors. They involve a healthcare provider, a care manager, a laboratory, quality manager, and a patient, of course, at the end of the day. And you have a complete schedule of what needs to happen if, for example, a particular patient has the symptoms diabetes 2 and how we can, of course, try to alleviate those problems. So we start from the patient visiting the healthcare provider, registration, information, vital signs, and of course symptoms. And what we try to do is we prescribe different types of tests. I'm not going to go through these tests, of course, because we don't have time. But the general idea is that you have a complete, let's say, schedule of how you can treat this particular patient. And you start by something which is very, very simple, which is the patient registering, and you end up here generating plans of how you can cure this particular, let's say, patient based on very, very specialized, let's say, tests. HCA1C is a very specialized test for people who suffer from diabetes type 2. And this is, of course, a simplified picture because the concrete picture that the medics are using is much more complicated than that. But I hope that you get the idea. The next thing in line is something which is very interesting. And what we're talking about now is we're talking about something completely different. So far, I was talking to you about things which are very connected, if you wish, to the business case, to the problem in hand, which is the diabetes 2 patient, and how we're going to cure her or him or whatever. Now, we talked about stakeholders, about medical pathways and the like. Now, all of a sudden, we're becoming very technical because what we have to do is we have to throw into the mix the requirements of the resources, and these are very important. So these are the resources that we need to deploy in order to be able to cure this particular patient. And as you see here, we're talking about MRI files and MRI images. And people think, oh, MRI images, well, big deal. Everybody does an MRI test. If you look at the requirements of those MRI tests, you're going to be wondering about the type of devices and information that you're going to use and store. So for an MRI image here, you see that basically what you have to do here is you create, let's say for pathological studies, 1 to 10 gigabytes of space for one patient only. So imagine that you have hundreds or thousands of patients, what types of requirements you have with respect to storage and speed and efficiency of processing power. This is enormous. So basically here we talk about 320 slice images of a multi-slice machine which generates something in the region of 1 to 10 gigabytes of storage, or at least requires 1 to 10 gigabytes of storage. Now, so let us delve into that a little bit deeper. We also have enormous network requirements as a result, because all this information is going to be broadcasted over networks. So basically, if we talk about 320 slice images, you're going to see that we need very fast networks. And this is the next picture. So these are the infrastructure requirements with respect to the networks, CPU capacities, network requirements. You have, of course, 24/7 availability, fiber links at the speed of 750 to ensure connection is maintained all the time. And you see here it becomes very specific with the type of technologies that you have to have for your networks. And of course, at the end of the day, what types of virtual private routed networks you're going to use, the LAN services, the e-pipe networking, and the like. So at the end of the day, as you see, if we want to deal with an application, you need to take not only into account the nature and the context of the application, but also the resources that the application is going to use at the end of the day to solve the problems, as well as the stakeholders. And I gave you some glimpses of that. Now, if we delve deeper into these applications, we're going to see that there's a hell of a lot of standards which are very important and they need to be, let's say, adhered to. And these standards, let's say, concern data standards, vocabularies, terminologies, what have you, like SNOMED. You have information standards and interoperability standards, like the integrated healthcare enterprise, information exchange standards, which are message-based and structured document-based standards, identifiers, privacy and security, functional standards, and all sorts of standards. So there's a hell of a lot of standards that you have to take into account, and you need, of course, to observe and to satisfy at the end of the day. So these are also thrown into the mix, and they become part of this 5-to-5 model, if this is going to work at the end of the day, or any type of model that you're going to use to solve the problem. So this is in a nutshell these types of applications that I mentioned to you, and this is how we try to organize the information, the services, the standards, the stakeholders, the resources, and so on. So I just gave you a broad picture, and let me get to some of the challenges. There's an enormous amount of challenges here, so I'm going to highlight a few challenges because simply we don't have so much time anyways. Now, one of the biggest challenges is understanding the application context and the requirements, and of course, if you wish, the application engineering. So, if we look at the characteristics of these applications very quickly, we're going to see they're purpose-built, they're very dynamic, they're never static, of course, they're human-centric, they're collaborative, they involve a lot of stakeholders like you saw before. They're data-intensive and service-intensive. They have analytics built into them. They have instant visibility. They combine people, data, services, and IoT. In other words, the industrial internet. They require in-depth business domain and support infrastructure. We saw that. All sorts of knowledge requirements, architectures, reference models, and so on. And they have, of course, security and privacy as a first-level design and deployment concern. So there's a lot of requirements and a lot of, if you wish, characteristics which underlie these applications. So these applications are quite complex, as you see. Now, some of the, let's say, if you wish, challenges here relate to the fact that a lot of people start solving these applications without applying any techniques, any methodologies, any sort of, if you wish, software engineering or service engineering or data engineering principles to them. So the market is fragmented, it's very complex, current solutions are closed. Let's skip this slide. And let us come to this one. So the application development context is very, very weak. So we have enormous problems. So if we look at the customers and the requirements, here are our patients, for example, and the line of business, which is the healthcare and the diabetes too, we have one gap between the line of business and the development team. So these people don't understand each other. And if you apply techniques like agile development, this is really fine, but you have to understand the application or the business context here. The next gap is between the development team and the operations team. So these are the traditional operations team which operates the infrastructure. So there's another gap there. So these are things which have not been solved adequately today. So, of course, some of the challenges is scale, complexity, evolution, time pressure, and the like. So the first gap, you can use all sorts of information technology or software engineering sort of, let's say, tools like ITIL, for example, of how you can have, let's say, how you can apply service management techniques that focus on the alignment of IT services and business needs to solve this gap. You could, for example, but this is not adequate. You need more specialized solutions, of course, but this is the first step in this direction. If you want to bridge the second gap, then you use something which is called DevOps. And DevOps is development operations principles, and you try to solve this gap between development team and operations team. And of course, you always need to take time to improve. The problem is, like I mentioned to you, and this cartoon is very, very topical, is that people always try to use shortcuts to try to solve the problem by completely, let's say, bypassing the area of application development. And they use all sorts of ad hoc techniques. And at the end of the day, all these solutions, unfortunately, are not going to be completely adequate. They may solve a particular problem, a narrow and focused problem, but they're going to miss a lot of other problems. So we need to apply these techniques. And of course, unfortunately, this, as you know very well, it takes time. Now, how do we build those applications? We go back to the first slide that I mentioned to you. We recap the situation here. We start by creating these data lakes, which is the data orchestration that I mentioned to you before. Input from various sources, cataloging, orchestrating, cross-correlating, and the like. And we use a lot of metadata and, of course, the security conventions. The next thing is we create data and knowledge as a service here. Self-services, of course, and we throw to the mix compliance, security, and privacy, and of course context-based discovery and exploration, knowledge provisioning, and the like. Then we have analytics as a service, and I mentioned to you analytics already. And finally, we end up with a smart application. So you need to follow these steps to try to solve these applications in a meaningful way. So if you wish, your software engineering needs to be very, very specific to the context and the requirements of those applications, and the service or software engineering techniques that we have today are unfortunately not adequate. You need much more than that. And basically this means a lot of research opportunities for you young guys who are at your PhD level or at the early stages of an academic career. So these are areas which have enormous implications for the future, and of course for conferences like the Conference on Web Engineering, and these conferences which look at different aspects of software engineering and software engineering techniques. Now finally we're getting to support frameworks, and I'll sketch a support framework, and I'll close my presentation because we're running very quickly out of time. A support framework is a reference architecture which is based on Intel. Intel has some believe it or not, Intel has developed a reference architecture, a very prominent reference architecture for healthcare applications. What I did is I borrowed some of the ideas which I complemented with mine. So basically here you have your data, internal data, health records, lab data. You have external data, environmental data, lab data, all sorts of environmental data like geospatial information, socioeconomic data, and so on, nutritional data and the like, which you try to cross-correlate and contextualize. Here you have your data and knowledge processing, data ingestion, integration of data, data cleansing, correlation, advanced metadata, ETL processes. Here you have the part of the analytics platform, and all of these analytics techniques that I mentioned to you, prescriptive, descriptive, predictive, they apply to this particular sort of framework. And finally you have here, if you wish, your advanced user interface, your visualization, your 3D images, and of course the virtual reality techniques that I mentioned to you before. And at the top of that figure you have your smart application, your smart, if you wish, healthcare application that cures or tries to cure at the end of the day, let's say diabetes 2 type patients. So this is in a nutshell the framework that we could apply, the reference architecture that we could apply, and as you see, this is also complex like the methodology that I suggested to you before. So we're dealing with very, very complex applications, and of course a lot of complexity requirements. So let me summarize what I presented. So what I did is I talked to you about smart data and smart application. The context of the talk was, of course, how we use smart data to solve smart applications. And like I mentioned to you before, these applications and the solutions are optimized. They're quite customized. They refer to the problems that a specific patient has. They're demand-driven. So they involve spontaneous collaboration. They're very dynamic. We don't have to wait. We have to exercise ingenuity, and we need to collaborate with other people and stakeholders to solve the problems rather than waiting ourselves to get information from the external world and being reactive. So we need to be proactive here. And of course, these are sustainable. They lead to compliance and long-term solutions. Now, we transit from owning and operating dedicated assets, including people, expertise, and equipment, to sourcing, orchestrating shared resources, services on a global scale. And this is a message that I want to leave with you today. These applications, like I said, are very complex, they're very distributed, and they involve a large number of stakeholders and resources which are widely dispersed and which are used in tandem, if you wish. So we talk about resources and services on a global scale. Customers pushing demands. Read here, patients pushing demands, of course. They're more device-centric, so you can use any sort of device. You can use mobile phones to interact, of course, with all these types of applications and systems. You can use laptops or whatever. They're very human-centric and collaborative in nature, and they're much more knowledge and information demanding and driven, and they need to be optimized and automated. So this is in a nutshell what I tried to present today, and this is, if you wish, a summary of the main points of my presentation. So thank you very much for being here and for listening to my talk and bearing with me today.
We have time for some questions.
Speak up. Thank you.
Maybe approaches like, I don't know, blockchain.
Good.
This kind of I don't know how far
we're not very far. To be frank with you, we're looking, basically I'm trying to sketch the future here. I always like to give people grand challenges to my students. So at the beginning my students hate me because I give them very, very complicated problems. If they survive, they survive. At the end of the day, they're much more experts than me, and they appreciate that. But it takes a long time to get there. But trying to put things into context, we're talking about how the future looks like. So the future is not one particular solution. It's not data engineering, it's not service engineering, it's not software engineering. It's a bundle of technologies which we need to look in a holistic way. Unfortunately, from my experience as a researcher, and I've been a researcher for 30, 35 years, what we try to do today is we don't look at the big context. We concentrate on very small, focused problems. In my view, this needs to change. So the challenge is to change our mentality as researchers, look at very big, challenging problems and try to contribute to these problems. And these problems are not going to be solved by one team. They're going to be solved by many teams working together. So another dimension which I foresee that needs to happen in the future is you have teams of researchers who are trying to collaborate with other teams of researchers and contribute to parts of a problem. So you need to be very, very focused. The traveling salesman is an example which is beaten to death. If I ask to review a paper that has this example, the paper is dead. I don't read it. It's a trivial example. So you need much more complicated, much more meaningful examples and much more meaningful solutions. You mentioned blockchain. Yes, it's an interesting technology. It can contribute to that, but it needs more than that. It needs analytics, different types of analytics, machine learning, and so on. So we need to open up and we need to work with other, if you wish, researchers and other disciplines. In computer science, believe it or not, there's a lot of segregation today. People are working in databases, they ignore what happens outside. People are working in AI, they ignore what happens outside AI and so on. This is very, very unfortunate. It doesn't work that way, believe it or not, in the domain of medicine, the medical researchers, or in the domain of, let's say, mechanical or manufacturing engineering. People are working together. We are working in separate teams, and we don't collaborate, and a lot of interesting ideas get lost, and this is the problem that we are facing. So we need to work together with, let's say, other colleagues and try to look at problems which are global problems rather than small focus problems. So we don't want to solve deltas. We want to have to make, if you wish, big impact, and this is big impact for me. So I guess I sort of tried to give you an answer which is broader than what you asked, just to point out where the problems are.
Okay, thank you.
More questions?
Yes, Antonio, it's a critical question. I need to do.
Because you're talking here about research opportunities.
Exactly. I mean, this is the idea is I'm not talking only about a domain of, if you wish, application and so on, but I'm talking also about, at the same time, research framework, research opportunities as well, because I think this is much more important than presenting just a topic.
But what about business opportunities? In the sense, sometimes
I gave you some numbers, huh?
yeah, but these are numbers. But I mean, it's not. I'm talking about concrete business opportunities, so identifying, because the industry goes in parallel many times with the research community. We work in interesting problems for us.
True.
But we don't think of business opportunities for the industry, which can be some kind of a common ground for industry and for us to cooperate. Otherwise, I think we're talking about research opportunities, but not about business. Not now.
You opened up a can of worms.
That was mine.
Critical as always, eh? Yes, absolutely. I couldn't agree more with you. I think the problem is that our research needs to be pragmatic. Ivory tower, esoteric research, high-level research, it may generate some impact, it may generate some citations, but this is where it stops. So like you said, you need to look at concrete problems, you need to look at what the industry is doing. I'm not saying what industry is doing is good, because in some cases, industry is very, very biased, and you know it better than me. So what you need to do also is you need to change the mindset of industry as well. You need to educate them, you need to take them by the hand and push them forward, and then you need to agree with them. If you take into account of what they say today and the problems they have, then of course you're getting a completely different type of research, which is going to be purely industrial research, which I wouldn't like. So you need to try to, of course, explain to them where the future is and the future opportunities, the future problems, and then you identify business solutions and business, of course, opportunities. Because there are a lot of business models that you can create here. But then again, if you don't have any funding or any sponsorship, then you don't achieve too much. And it comes to what you said. So you need to work, unfortunately, with business, but you also need to work with, of course, the public domain as well. So you need to educate these people. So it's a tall order. And this is for people who are established, like yourself, who need to move and shake, a lot of operators at the end of the day.
Thank you, Mike, for the presentation. So my question is more about what you said in the first answer. On the European level, yeah, so we have always a problem of fragmentation, and you have also led one of these networks of excellence. And now there is this European Institute of Technology, and there's also this health area. Have you any comment on that? Is that a successful thing? What do you think? What will be going on there?
I can talk here on personal experiences, and look, there are a lot of developments which are good in the context of the European Union, and a lot of developments which are bad. For me, one of the worst developments is H2020. I don't believe in H2020. It's a nightmare. The FP7 program was much, much better because it had a lot of research also. The H2020 is like what Antonio said, this industrial research. Basically, you take a small problem that an industry, A or B or C has, then you try to solve it, you try to market your solution, you try to sell it. For the life of me, you need to do that in 3 years' time. For me, I'm not a proponent of that. If you go back to the FP7, you had networks of excellence, and the networks of excellence were an excellent instrument. What they did in H2020, they cancelled them. So you had a lot of people working on pure research, you had industry working together, like Antonio said, trying to look at it from the business perspective, business opportunities, which I think was brilliant. But then again, they don't exist, these instruments. And at the end of the day, we as academics, we are forced to knock on many doors to try to get, let's say, funding for our research. And in my view, the European Union is not doing the right thing at the moment, simply because they're looking mostly at the requirements of industry and not the academics. And for academics, they say, oh, well, you have the national bodies in Spain or in Italy or wherever you are, just go knock on doors, get some funding. Yes, it's fine, but it doesn't work on a larger scale. We're not competitive, unfortunately, and we're falling behind. So, unfortunately, politicians have a completely different mindset than we have. So, I'm not very optimistic. I'm a very optimistic person, but insofar as what you mentioned, I'm really worried that we're moving in the wrong direction, simply because we as researchers cannot influence these processes. And we are forced to follow them. We do have a lot of H2020 projects simply out of necessity. We try to do some research, but basically you cannot do, let's say, strategic research or sort of, this type of research that you used to do in networks of excellence, unfortunately. Maybe my answer is biased, but I don't know, other people may have different experiences, of course. So it's very subjective, so take it with a pinch of salt.
Okay, Mike, thank you so much.
Well, thank you.
In our invitation.
Thanks so much.
Only two things to organizational issues. Please bring your ticket for the lunch. Second, for the social event of this evening, also bring your ticket. It will be required on the bus. Right? And now for the lunch, follow the organizer with the t-shirt, with the yellowish t-shirt, right?
Regarding the lunch,